Which one's the one that has stronger? What album?
I'm trying to be your
That's the
friend.
purple album. No, I'm talking about the purple album. You never listened
I've
to
listened
it?
to all of Kanye.
I'll look it up.
Not a huge Kanye fan. I am as like a producer, but as a rapper, it's just okay.
No, he's a pastor.
All right, so here we go.
Is this notes?
Sure.
Yes.
Okay.
So, first things first, let's have a debate.
Yeah.
What is an isosceles triangle?
Burning.
Two sides are the same. Beautiful, great, fantastic. Isosceles or no? Go.
Yeah, this is a
Equilateral.
graduation.
You say it's equilateral. Does that mean it's not isosceles?
Yeah, it's not. Okay, equilateral and isosceles are different things.
Sit down. I don't care.
At one point-
No, do not care.
You're jealous.
Don't
No.
care. I still don't care.
I mean,
I mean, all three sides are the same. There's not
That's
two
true. It
sides.
is equilateral. All three sides are the same. Does it count as isosceles?
No.
yeah,
because
it's two
All right, we have
sides.
some people say yes, some people say
No,
no.
it's three.
You say no because we have three sides that are the same, and isosceles has two. Who says yes?
Yes, because there's still two sides that are the same.
Right, so there's two ways of thinking about this. So there's your way that says, no, they're completely separate, they can't be the same. And then there's Laney's way that says, well, isosceles only says we need two sides the same, and I see two sides, so it counts. And that's the way we're going to go with in this class. I'm not saying it's right, I'm just saying that's what we're going to go with. And the reason for that, okay, no, it's fine. Both are valid answers, they're not wrong. The reason we're going to go with that one is because anything that's true for an isosceles triangle, more or less, will be true for an equilateral. So, for instance, this isosceles triangle theorem will apply to both, even though technically this one's an equilateral. So the logic here is that an equilateral triangle can be considered isosceles, right? It has two sides the same. But an isosceles triangle can't always be considered an equilateral, right? For instance, here's an isosceles triangle. It's not equilateral, right? So it's directionality is what we're talking about here. So the theorem. And remember, theorems versus postulates, theorems are proven, right? We can back those up with other postulates and other theorems. Postulates are leaps of faith. It's like, this has to be true, there's no way around it. I can't prove it, but it has to be true. Now for you guys, when you do that on a quiz or test, it means you don't know how to do it, right? But for geometers, we can just say, man, it's gotta be, right? And we'll call it. So we call it a postulate. So a theorem is something to be proven. We're gonna prove this down here. So what is the theorem? It says, if two sides of a triangle are congruent. Well, that sounds like we've got an isosceles there, bud. Right? So we have two sides of a triangle congruent. Then that means that the angles opposite those sides are congruent. So here we are, right? The angle opposite this side is this angle right here. So that means this is going to be congruent. This side, right? Opposite angles there. So this theorem says that if you have an isosceles triangle, right, then that means the angles that are opposite those sides will be congruent. So if two sides of a triangle are congruent, then the angles opposite those sides are congruent. That's the concept. So is this an isosceles triangle?
No.
Why not?
No, I'm just playing.
Is it or is it not? It is, right? It has two sides congruent, right? They're both the same length. I use two little pieces, right? Which then means we know these angles are the same automatically, which is pretty rad. We know that by this theorem. Now, we're going to prove that theorem in a second. Before we do that, let's talk about the converse of that theorem. The converse means the reverse, okay? So not all theorems have a converse that is true. Sometimes when you flip them around, it doesn't make a true statement. But this one is true when you flip it. So if we take these two things and rotate them, right, switch their spots, we'll get a true statement. So I'm going to write the same thing. If, and then instead of talking about the sides, I'm going to talk about the angles. So if two angles of a triangle are congruent, then we've got the two sides opposite are congruent. So then the two sides opposite, the angles are, so words are hard, math is easy. Okay? What this means is that if we have two angles congruent on a triangle like this, then we know what that means. That means that by this converse theorem, the reverse of this theorem, right, that we get that for free.
Nice.
So if we have two matching sides and we have two matching angles, if we have two matching angles, we have two matching sides. One is the regular theorem, isosceles triangle theorem. If you have an isosceles triangle, then the angles are congruent, right? The two bottom ones. And then the converse is, if you have two bottom angles congruent, then you have an isosceles triangle. Yeah.
What are the two words before congruent?
the angles are. So the two sides opposite the angles are congruent. So see how we have two angles here? The side opposite this angle is this side. The side opposite this angle is this side. That's what it opens up into, right? So we're going to prove that theorem, and then once we have it proven in general, we'll be using it to prove other things, right? But first we're going to prove that theorem true, right? I can tell you that this is true, but I'm going to show you that it has to be. So much like when you write the definition of something, like the definition of dog, you can't say, well, a dog is a dog that, right? You can't do that. You can't use the word in the definition, right? So we're not going to prove this theorem using this theorem, right? That would be silly, right? How do I know that these guys are going to be the same?
Silly goose.
Well, this theorem says so. Well, I want you to prove it, okay? So it says right here that CA and CB are congruent. So I'm going to do that on my diagram. And they gave us triangle ABC. Here's triangle ABC. Now, it doesn't matter how they draw that triangle, because remember, it's not drawn to scale. I was kind and drew it to make it look like isosceles, right? It doesn't have to be. The drawing could look like a really crappy triangle, right?
So basically, that's how it's going to be on the quiz.
More or less.
Well, not that picture, but the crappy version.
It could be, yeah. There are cases where it's not going to look isosceles, but we've proven that it is, right? That can happen sometimes, right? Drawings are just drawings, right? It's just a drawing. All right, so now we're going to prove that angle A and angle B are the same thing. So we are not given that, so don't mark that on your diagram. We don't know that. We're trying to prove that that's true, okay? So a couple things you need to know. First off, there's a postulate that we've never really talked about that we should. Remember, postulates are something we accept to be true because how could they be anything else? And this postulate I like to call the let there be line theorem, or let there be line postulate. And the logic behind it is that no matter where you stand, you can drop a line, and when it drops, it'll drop at a 90-degree angle. So once it's set still, you'll see it hits the bottom of the floor at a 90-degree angle. Now I can stand at an angle like this, right, and that's going to change things, but if I'm standing on a point, and I drop it straight down, it's going to hit something at 90, right? So think you're a spelunker in a cave, right? You want to drop your rope down before you do the Mission Impossible slide, right? You're sliding down to the bottom of the cave, right? That's going to drop at a 90-degree angle. If it didn't, it would end up dropping like this, and that'd be very weird, right? I'd have to like throw it like this, and then like, I'd have to throw it like this and just kind of let it go where it lies, right? And you can see it wants to go 90, right? That's why it bends in the middle. So the idea is no matter where we are, we can always drop a 90-degree line, and that's legal. It's totally fine. So what we're going to do is right now, there's nothing we can do with that, right? What we're going to do is we're going to drop a 90-degree line from C, the top of the cave, all the way to the bottom. So you don't need a protractor. You can just say that it's 90, right? I'm going to do a straight line, and I'm just going to say that's 90. We're just going to call it that. Doesn't matter if it's exact, right? The nicer you make it look, the better it is, right? But in general, if you say it's 90, it's 90. So the way we write about that is we say let there be, kind of like let there be light. Whenever you say let there be, you're creating something, right? We created something on our diagram that wasn't there before. So we're going to say let there be CD perpendicular. Now, CD is the segment I created, right? What is it perpendicular to? What other segment?
CA.
Not CA. CA is over here.
Oh! Sorry.
CD is perpendicular to what?
I need to look at
AB. Now you're allowed to do that on any drawing ever. That's kind of like an auxiliary line that we used in our proofs last semester, right? We occasionally had to draw in an extra line, right? You're allowed to make a line whenever you want and say, that's 90, so says me. Okay? So we've said that, we've created 90, and not only that, but we've created two triangles, haven't we? Right? So what we're going to do, the plan is going to be to get as much information about these triangles as possible, prove that they're the same triangle on either side, and then use those triangles to prove that A and B are the same angle. Okay? Yep, something like that. So we're going to try and get as much information as possible. What information do you see on this diagram that I can now add? They're sharing a side, right? So I know that CD is congruent to itself by shared side.
Cool. How can a line be congruent to itself?
All lines are congruent to themselves. So the reason we have to say that is because there are two triangles here, Justice. There's a left side triangle and a right side. And we're making it clear that we have one of the legs of our triangle matches the other leg. And the reason we know that is because they share that side, right? They're sharing it. So it's going to be the same on both triangles. The length on this triangle is going to be the same as the length on that triangle. We're just saying that. Now it's obvious. Why is that? Because they're sharing, right? We just gotta state that. That's all.
Okay.
So, we don't have enough information to prove these congruent yet. If you look on the right side though, we have a 90-degree angle, and we know our hypotenuse and we know one of the legs. So we could use HL to prove this congruent to that, right? But there's a problem. We can only use HL on 90-degree triangles. And we know this one's 90, but we don't know this one's 90 yet, right?
Right.
So we need to figure out a way to make that 90. Now, it's gonna be 90. I mean, look at it, come on. It's gotta be.
Just gotta prove it.
It's gotta be, right? But we gotta prove it. So here's how we're gonna do it. Remember last semester, we had a thing called linear pair theorem. And linear pair theorem said, if you have two angles, like this angle here and that angle there, and they form a line together, then they must be supplementary. Remember that?
I always thought as if they shared the line.
Something like that, yeah. So by linear pair theorem, we know that these two angles are supplementary, and then by definition, supplementary means what? They 180, right? And then by subtraction, if we subtract 90 from that 180, what's left over? 90, right? So last semester we'd write all that, right? We do substitution, we do subtraction, all this crap. We're just gonna say by LPT, that's 90. Because we're in semester 2, boys. So measure of that angle. Let's name that angle. That's angle ADC, right? ADC equals 90. Oh yeah, feels good to skip all those steps, doesn't it?
Yeah, it kind of does.
Right? Linear pair theorem means they're supplementary. By definition, that means they add up to 180. Then we do subtraction and we get 90 left over. Therefore, this is 90, right? But we just did it all with LPT. Okay. So now that we know that that's a 90-degree angle and that's a 90-degree angle, we know these are both right triangles, so we can use HL, right? So let's do it. By HL, we know the triangles to be congruent, right? Because their hypotenuses match and we have a leg that matches. So let's write that. Triangle, I'm going to do ACD for the left triangle. Again, I tried to write in alphabetical order for the first one. And then the other triangle, we have to match up the letters. This is super important, okay? Just like we were doing on our quiz. So notice that angle A on the left triangle, is made up of the hypotenuse and the unknown side, right? That's what makes up A. So if we go to the other triangle and look at the hypotenuse and the unknown side, it's going to be B, right? So A and B go together. C on the left side triangle is this angle up here. It's made up of the hypotenuse and the known leg. So hypotenuse, known leg, it's going to be congruent to itself, right? Not always will C be congruent to C, but it is here because hypotenuse, this, hypotenuse, that. Yep. And again, looks can be deceiving, so we can't just go, well, it should be folded, right? Right? Make sure you check the sides. So D on the first triangle is this angle right here. It's made up of the unknown leg and the leg we know. Unknown leg we know, it's D. So it turns out C and D go with each other. Convenient. Now, that's not what they wanted. Yesterday it was like, oh, we proved them congruent, move on, right? Today we want a little bit more. We want to prove that angle A and angle B are the same. So here's the next step. This is a theorem, it's super short. It's going to be confusing at first, but it's a really simple thing, so try not to overthink it, okay? But you will, and it's okay. So here's my logic. I have two triangles. They are congruent, right? I'm telling you they are. Are their parts going to be congruent then? Yeah, right? See how this guy and this guy match up? So they're going to be congruent. So if we know they're both congruent, we know that there's going to be parts here and parts there that match up, right? For this one, it's these two match and these two match and these two match, right? This angle and this angle is the same as that angle and that angle. And then these angles match, right? So what we're saying is that if we know the triangles are congruent, which we do because we just proved that, then we can say their parts are congruent. Does that make sense?
So by ITT?
So we're going to say by corresponding congruent parts, by CCP.
Wow.
Okay? You're going to get used to writing this a lot. Corresponding congruent parts, that's what it stands for. It means parts that correspond are congruent. Remember corresponding angles? It means they're in the same relative location, right? Well, check it out. If you've proved the triangle's congruent, you can use CCP. You got to do this first, and then you can use CCP, okay? Notice that A and B are in the same relative location. See how they're first?
Wow.
That means they must be congruent by CCP. So CCP says, if the triangles are congruent, then their parts must be. And the parts that correspond, that's what that first C stands for, corresponding congruent parts, then those must go together. So A and B must be the same. So we can write A
That part's really simple for that.
congruent to B. It can be if you don't overthink it, right? But I would like you to wrestle with it a little bit and really understand it. if the triangles are congruent, which we proved they were, then that means their parts are congruent. We were doing that when we were matching up their letters, right? We were trying to figure out which ones match which. Well, because A and B are in the same location, we know that they're congruent. What's the reason that allows us to do that? Hey, look, they're in the same location, they must be the same, right? Well, it's because we know CCP is true. And when we write our congruency statement, we make sure to write it carefully to make sure they actually do line up correctly. Yeah?
I have a question. So, like, would there be a question in the future that shows the two triangles not matching, or would that not be the right?
It could be possible that the triangles aren't congruent, and then you're kind of
That
screwed,
would be the question.
right? I might ask you to prove something, and I might say, hey, some of these are provable, some of them are not,
Oh.
right? But in general, we're worried about proving things that can't be proven true. Okay? I don't throw a lot of curveballs, and when I do, I tell you ahead of time. Right? So, yes,
Okay, so say this is on a quiz. How many points would this be?
I have no idea, man.
He's gotta go as we go.
Anyway,
I'm saying back.
like a dead cat, we're gonna back up and go over it again. Okay? So stay with me. Okay?
Never say that again.
I'm sorry, I used to have cats.
That is that.
That is not funny.
I had 2 cats.
That is hilarious.
That's not
They live in
funny.
Vancouver,
That's
Washington
hilarious.
now.
It's okay. It's okay.
Nothing.
No, don't.
You said like
So-
a dead
no,
cat.
don't say it. She'll start crying.
Go back over or something.
No, I said.
She's
like I
a
said,
cat right back over.
He's like,
May I
look at that
say-
cat.
Let's go back and run it back
Jenna,
over again.
I said, like a dead cat, I'm gonna go back, I'm gonna back up and go over it again. Okay? So I'm gonna back up.
You done messed up, brother.
Now
You
she's
done
gonna
messed up.
cry.
Everybody said I didn't have jokes this semester.
Here comes
All right.
the waterfall.
So, it's
Random
okay.
people have dead cats.
What?
It's already dead.
Like
It's
a
already
dead
dead.
cat.
It's okay, I used to have 2.
Run back over. What were their names?
It's
Bernie?
already dead. Its feelings are
He burnt some
Bernard.
rubber.
Don't.
And River.
Tana.
Ghosts.
That's not us.
And now they live in
That's
Vancouver,
not us.
Washington.
She's trying to
God.
say something.
Don't bury me.
Dang, she's like.
Alright, so we're backing up and going over it again. Here we go.
You got some dark
Let there
humor this
be.
semester, bud.
I'll never say the joke again. I probably will say back up and go over it again though.
We're
So like,
so
you'll think of it.
Make it like a
Say it like a frog. next
Chance
time.
thought it was funny,
Yeah, say like
didn't
a
you?
frog or like a snail.
What's the difference between a frog and a cat?
You're stupid. One's a amphibian.
We're just trying to make it easier for them.
One's a mammal.
We're trying to make sure that they don't
Animals.
cry.
Cows die every day for you, so I mean.
They're good
Jeff
food.
Maxon
Well, then
sacrificed
go
his wife.
vegetarian. That's
Facts.
a solution.
Alright, so here we go.
Sheep is-
Is everybody good with the idea that we can drop a perpendicular whenever we want? You have powers. It's like Matilda, right? You can drop a perpendicular whenever you want. Okay, so everybody good with that? Okay, next I said shared. Are we good with shared side?
Yeah.
Alright. Then I know that by LPT those angles are going to be 90 in each, because if that's 90, they should add 180, so that's 90 as well.
Use the weird one, the H, whatever. for
Can't
that.
use HL until I know that they're both 90-degree triangles, right?
You don't
HL
know
only
that?
works with 90. We didn't know that until we proved it. I knew that was 90 because I dropped it, right?
Oh, so
But then I had to prove the other one by LPT.
your HL's after that. Isn't it?
Yeah, yeah.
Is there gonna be questions that you like the triangle's not gonna be
Why is she sitting on
90
this?
degrees?
Whenever you drop it, you can create a 90-degree triangle.
Okay, so like okay.
So, for instance, and I can prove that really quick. I can't prove it, it's a postulate, but I can show you why that makes sense. So for any triangle that I have, like even this one, I can drop a 90 degree right there, right? I can even rotate it, and I can drop another 90 degree right there.
So then every answer would include a element.
I can also drop another 90 degree. I can drop it right there. Look, they all intersect at the same point. That's interesting. We'll probably talk about that someday.
That was like
I hope that day never comes.
Don't do it yet.
I know what they're saying.
I got you, Mr. Man. Awkward
What
pause.
is the joke?
Yeah.
Oh my God, you gotta put in this. You gotta.
Go.
Buckets. Thank you. All right. I need that. I need a soundboard to do
No,
that.
you don't.
I'm tired of making the noise.
No.
Right? Myself. Right?
Okay,
Start
you
doing
know-
it.
Shush.
I'm about to start beating my head on this.
I want it for real. With those
We'll
speakers.
start
no.
beating my
I used to do that with the Inception noise. Remember that from the movie?
Don't beat your baloney.
Huh?
You're gonna beat your baloney.
That's calculus.
He's gonna choke his chicken.
He just said
That's how it is.
Are we good up to here?
That makes you blind.
Are we good up to here?
Kicking the can.
Solo sex?
Yeah, it makes you blind. Choking the chicken makes you blind. It stunts your growth.
My coworker at my uncle's job.
He is gonna flag this
No, I
video.
actually
All right.
said-
No, Jenna.
Lost for demise.
What?
No.
The cat's dead
All right.
already.
Gentlemen,
Shut
Can I go
up.
bathroom?
Hayden.
Jenna knows all about
Can
choking.
I
Cat
just go?
croaked, alright?
I'm not choking the chicken yet. Can I go to the
No,
bathroom?
this
He
is-
said yeah. He's going
Yeah,
home.
yeah.
He's going home.
You
I
know
will
what he's
say
about to
something.
do when he gets
I
home.
need to be excused.
all right, so here we go. What?
So did you know that when a bee finds a female?
No! No!
Talking about
No!
What? No, let me say this. When a bee finds a female bee, and then, they do their business, that
It's called
bee
sex.
dies.
It's called this.
Because
You don't brand it.
It's called bumping ugly.
that bee dies because the stinger or whatever, does that. It stays in
He
there.
bones it with the. Oh my
My
god.
guy!
Oh.
Easy.
Dude, I would not want to find that on
I,
You
I
may not
found
wanna
it
put this
on
on YouTube.
Instagram.
YouTube comments, please fact check that. All right, so here we go.
We're live.
Yeah, you're solid 65 subscribers will
Hey,
have.
Mr.
Right.
McAnally, I have a phone.
No,
Answer it.
okay.
Answer it.
No. All right, so we get up to here.
Yeah.
All right.
Chicken.
Oh god. Ew! Oh my god! Oh my god! Oh my god! Ew! Ew! Ew!
I hope you know he
Do I have
was
you up
smacking
here?
his leg, right?
Do I have you up here? Do I
I hope you
have
know he
you?
was just smacking.
All right, bring it back. Bring it back. Do I have you up to here?
I hope he
Justice, do I have you up to here?
Yeah.
Awesome. LPT gets us the other 90. Now that we know that we have 90-degree triangles, we have legs that match, and we have hypotenuse that matches, right? Then we can use HL. Now the triangles are
You're
congruent.
gonna have a stroke.
Lastly, come on, bring it in. You're going to get screwed in the next one, okay? So CCP. If the triangles are congruent, then their parts are congruent.
Oh,
okay?
God.
You're in the same spot.
Don't bring it.
Hey.
He can't even look at you.
Look over
That's
there.
disgusting.
Look over where?
Oh my Jesus.
Look over
Stopper,
where?
you forgot to clean up properly.
Look in the parking lot here, buddy.
Next one's on your own. Do number 2 on your own.
All right.
Wait,
Work together. 2, they give you the angles and they want you to prove the sides.
You put it on speaker.
Slobber. What are we talking about?
Oh my god, dude.
Alright, I'm gonna write
Remember
there.
Randy from South Park? when he-
Slobber. Remember what we talked about?
I'm gonna have an aneurysm.
Once you get on a roll, you can't stop. You gotta stop.
Let there be.
Can I borrow a pencil, Mr. Mac?
Yes, you may. Pen.
No pen.
Hey, well, Mike, just
Yo.
a question. So, since
Dropping
these
that perpendicular would be a good thing to do.
Since they have the kind of that same, can I use them?
What's the perfect?
We don't know this. They didn't that.
Drop.
That's what we're trying to prove. We're trying to do the converse, guys. We're starting with the angles and we're going to get the sides.
Do I have to?
Before, they gave us the sides in the directions, right? They said given CA and CB are the same.
Oh,
Now they've just given us the angles and they want us to prove the sides. So we're doing the converse, right?
CA,
Get on it.
So,
So what are we supposed to prove? That's equal to that, CA.
Yep, CA and CB, yep.
How do we-
Well, first off, you're going to want to drop that perpendicular, right?
Like that? Like
Yep, like that, and then you're going to have to write it too. Remember, drawing it on the diagram is not the same thing as writing it. You need to do both.
Hold on, Mr. Mac, can you show me the other side of your paper real fast?
So,
Hurry.
It's not the exact same thing, and my hint to you is you're not going to use HL. Because in order to use HL, you have to know what the hypotenuses are, right? And for this one, we don't know until we're finished, right? That's what we're trying to prove. So you can't use HL for the one on the back. You'll have to use a different triangle congruency theorem.
son of a
That was hilarious.
That was very funny.
He went into the bathroom. He just had to go for this.
Gentlemen, we got to be done now, though. You know I'm fine with it. We got to get stuff done.
so what do you mean by drawing it right in on the paper?
Well, the stuff we did there
I probably should have done
is
that.
going to go there. Luckily, I left it up there.
Pardon me for doing that.
This part right here, let there be CD perpendicular to AB. That's the thing you're going to need, okay? It's going to allow you to draw it.
So,
Whenever we say let there be, we're creating something, like let there be light. We're creating a perpendicular between CD and AB.
so does it have something to do with writing out how A is the same as B?
I mean, that's given to you,
Yeah.
so you're going to have to use those angles. Yep, that's true. What your job is to get as much information as possible, and then prove the two triangles congruent, and then use their parts to say that the hypotenuses are the same. So I think most of you will get up to about a certain point, and then from there I'll do it on the board, okay? All right, I'll be there in a second. Yep. That's good.
Cookie or something?
So marking it on here. Yeah. Or the quality. So now we know this is
Well, it's a little aggressive there.
Now, can we put
That's my point. That's my point.
That's why I put that there. You don't put it there, you forget, right? So now we know the triangle congruence, write that. And then let's type up there.
I don't know.
Nice job.
That's funny.
Okay.
I like 22
I'm not the one.
Yeah.
I got that. So does that mean, am I just caught doing what you
Nope.
did with no.
That one, they gave us the sides were congruent, and we had to find the angles. This one, they're giving us the angles, and we're going to find the sides.
So is that irrelevant?
Nope, that's good. And you said drop it at 90, that's what that means, right? So this is a 90-degree angle. So says you. Now what you need to do is get enough information out of these triangles to be able to prove that they're congruent.
Out of this one and that
Yep,
one?
those two.
And the tire or no?
Well, once we get these two triangles being the same, then that'll prove that these two sides are the same. Okay?
There's something to do, can I write out like how CB?
Yeah, just not.
Not CB. When we drop this, we're dropping C something. You have to label that point.
Oh, there's D.
We call it D. And then it's perpendicular to 80. That's what you're going to write here.
So,
Remember, perpendicular means it hit at 90.
Yeah.
It's hitting this at 90. That's why there's 90
CD
degrees there.
is hitting AB.
At 90 degrees, yeah.
I'm gonna be on World of Hurt next Friday. Wait, what's next Friday?
Quiz.
What day is it?
I don't know. February something.
Like,
February
what day is it today?
the 22nd.
22nd?
Shirt size. LPT.
It says Wednesday?
Yeah, nice job.
Wednesday or
And then we know
Thursday?
this is Well done.
Matt, can I have
I'm going to
Killing it.
say.
Yes, I will write you one at the end of
Today's
class.
Thursday.
Today is Thursday all day. No, today's Wednesday? Today's Wednesday all day.
It's the 23rd? 24th?
Yeah, one of these you got for free because you said it was
28th?
right?
But you have to prove it.
Right, the other one.
Oh,
Yeah,
it'll be
exactly.
the 31st.
But that's fine. That's fine.
I can write
Okay.
LPT since
Next Friday.
Right? LPT gets you their angle. Yeah. I think most of you guys have gotten to a certain point, so I'll start walking my way towards it.
Right.
Okay? Here we go. Again, it should feel a little bit like you're floating in space right now. You've never done one of these before. It's okay. But I think most of you guys are getting the hang of it. Okay?
I just don't get the hang of it because I didn't do it. It's my fault.
Yep. That'll do it.
Kind of my fault, not really.
Some of you guys are good enough where you can pay attention, only some of the time, and it'll work out, right? But you're gonna miss the little things that are gonna screw you over in the quizzes and tests, because when you don't pay attention, you're gonna miss those little things. But none of you are good enough to not pay attention at all and be okay with this.
Well, I mean,
Okay?
I don't know, man.
And I think you already know if you're capable of doing that or not. I think we figured that out first semester, right?
kind of.
All right. Cool. And there's no shame in I didn't pay attention at all in class and I can't get it,
There's no
right?
shame.
Right? I mean, that's not like, oh man, you're dumb. It's like, no, you just literally
Yeah.
like imagine it's like, all right, guys, we're having an algebra 2 test right now. And you're like, I wasn't there for that. I'm not in that class. It's like, too bad, right? If you're not in geometry, you're not paying attention, no wonder you don't know the stuff, right? I mean, that just makes sense. So just make sure you do the best you can. No shame in it. Just make sure you do.
Yes.
Slopper. Thank you. I know.
That's satisfying.
It is satisfying. All right, so first thing we're going to do is we're going to drop perpendicular to make two triangles, and then we're going to prove those two triangles congruent.
Yeah, that's right.
So dropping a perpendicular, I'm going to call it CD, just because why not? So let there be, because I'm creating something, right? Let there be CD perpendicular to AB.
Yes, I did.
Now remember, perpendicular doesn't mean you just drew a line. It means you drew it and you hit it at 90.
It's a very
So you get one of the angles for free. One 90-degree for free, okay? Now we're going to get the other 90-degree angle, or you could get the shared side. What do you want to do first, shared side or get the other angle?
I said shared side.
Shared side, most of you guys probably did shared side. So I know that CD is congruent to itself,
Wait.
and I know that by shared side. So far so good?
Hell yeah.
All right. Now, we're going to say that this angle is also 90, and the way we're going to do that is by LPT, right? LPT says both are supplementary, right? So if that's 180, and that's 90, that must be 90 as well. So by LPT, measure of angle ADC equals 90. All right, so far so good.
Wait, LPT?
Pretty much the same thing as before.
Linear period
We're just trying to get linear pair theorem, which says if two angles make a line together, which they do, right, then they must be supplementary. So if that's 90, subtract 180 from 90, or 180 minus 90, and you get 90 left over. Okay? Now, we can't use HL. HL says we have matching hypotenuses and matching legs. We don't have that, right? We don't. In fact, we know we won't ever have that because CA and CB is what we're trying to prove.
Yeah, but
So by the time we have matching hypotenuses, we're done, right? So we're going to use a different thing to prove the triangle's congruent. What do you have to
I
say?
thought that the isosceles triangle theorem.
Right. We're proving the converse of that theorem, so we're not going to use it. It's like using the definition. You can't use the word of the definition. Does that make sense? Okay. So yeah. After we do this, you can just say, well, by that theorem, I get these. Done, right? But we're proving that that works. Does that make sense? Okay? It's like you're out in the wilderness, and you have this like automatic fire starter, right? Push the button, there it goes, right? I'm showing you how to build one of those. That way, if you're in the wilderness, you can build one, then you've got it, okay?
It's easy.
Unless it's
all
raining.
Wood.
Nope, this one works even in rain. All right, so now we're going to prove the triangle's congruent. We can't use HL.
No.
What can we use? Lainey, what can we use to prove the true triangle's congruent?
AAS.
AAS. So check it out, guys. Angle, angle, side, angle, angle, side.
Is it alright if I said side angle?
Yep, that's fine. Remember, forward and backwards are the same. That's fine, right? You just can't rearrange the letters. So by angle, angle, side, or side, angle, angle, either way works, right? We know that triangle ACD, I'm going to try and write in alphabetical order, is congruent to the other triangle. Let's make sure we match up our parts. So A is the hypotenuse and the unknown leg.
And B
The hypotenuse and the unknown leg is B, so A goes with B. It's the same as before, right? C is going to go with itself because hypotenuse and leg we know, hypotenuse and leg we know. And then D goes with itself because leg, unknown leg, leg, unknown leg.
Nice.
Cool?
I like it.
Now, we're not done. We need to prove that CA and CB are the same thing. So what we're going to do is by CCP. Remember, you can't use CCP until after you've proven the triangle congruent, which we just did. Okay? So now we want CA and CB together. So check it out. Here's CA, and here's CB. They're in reverse, but it's okay, right?
Same.
They're in the same corresponding spot, so they are corresponding congruent parts. So that way we know AC congruent to BC. Oops, I want it the other way around, right? CA, CB. We want it exactly like they had it at the top.
Can we just do that?
That's corresponding congruent parts. It says if the triangles are congruent, then their parts are congruent. Which
Alright, I
one's
like
the ones
this.
that correspond? And notice how AC and BC are in the same spot, so that means they correspond. So they're the same. Yes.
I have two questions. Is it okay if I put like triangle ADC and triangle BDC?
ADC, BDC. Yeah, because they'd be in the same, they'd still correspond, yeah.
And like the setup through all like the steps, is that just gonna be basically the same for like any triangle like this?
It's going to be similar, right? The concepts, right? Don't worry about memorizing this. The first thing is we want to get as much information about the triangles as possible. Sometimes that means creating triangles, right? But we want to get as much info as possible, then prove them congruent, and then from there we'll have lots of information, which might even lead to this. That's the concept, okay? How do you feel about this one?
I love it.
Feeling better? Do I have you up to here?
Yes. I got up to there and then I just needed help with the last
What
one.
about here?
Yeah.
Okay. Does everybody see why these are congruent, angle, angle, side?
Yeah.
Great. The last step is CCP. That if the triangles are congruent, which they is, right? We just proved it. Then their parts must be. Which parts? The ones that correspond. Same relative location. Yes. So, fun fact, we can also prove that AD is the same thing as BD. Because look, AD is in first and third position, and BD is in first and third. So that means they're congruent.
I have a question.
That's kind of fun. Yeah.
So if that's an isosceles triangle, can you just, I don't know, this sounds weird, but can you just shorten it up to like, if it's an isosceles triangle and you divide it down the middle, all of that must be true?
That will be true, and we've proven it. Your job is to back that up. Right? The theorem is the shorthand, right? It's saying, look, this is true, right? And that's the shorthand. We'll be able to use that theorem someday, kind of like LPT, how we just kind of skip through it, right? But right now we're proving it. Tomorrow we're going to do more on this, and we'll have some more examples. Before you go, real quick, let's see if I can do this. Oh no. Did I lose my paper? If not, we'll talk about it. Oh, I got them. Here we go. Real quick, some basic definitions. I will get you a new proofs toolbox with more. But here's some basic ideas. Hopefully you can grasp it. By definition, B is the midpoint of AC. Does that make sense?
Yeah.
Yeah, you do.
BD is a bisector. It bisects AC. Bisects means to cut in two, right? What angle does it hit it at? I don't know, but it does cut it in two. Here, if we say it's a perpendicular bisector, it means it cuts it in two and hits it at 90. Here's an example of a bisector, but not a perpendicular bisector. So far, so good? Lastly, we can bisect angles, cut an angle in two. DB bisects this angle in two pieces. And then lastly, if we have a point that's the same distance from both sides of the angle, that means the line that it makes cuts the angle in half. So if the same distance from there to there, then that must cut the angle in half. Any point on this line would be doing that.
Can we go over this again?
Oh, of course. It's real brief.
This is true.
Can I have a pass?
No, fantastic day.
Or go.
Go away.